Hi, welcome to this Blender video tutorial entitled NURBS Curves, the Basics. The word NURBS stands for Non-Uniform Rational B-Spline. The Blender NURBS curve object is similar in nature to the Blender Bezier curve object discussed in a number of earlier video tutorials. Although the two types of curve objects are certainly different, each having its advantages and disadvantages, in some modeling strategies they are used interchangeably, as both are quite suitable for defining curved shapes. To demonstrate the Blender NURBS curve object, I have a blank Blender scene displayed in top orthographic view. I will press Shift-A and add a NURBS curve to the scene. I'll tab into Edit mode. Like the Bezier curve, the NURBS curve is controlled by a number of control points, usually called control vertices. The default NURBS curve has 4 of these control vertices. Like the Bezier curve, the NURBS curve is non-uniform. That is, the distance between the control vertices is variable, and control vertices can be placed or moved at any interval. Unlike the Bezier curve, the NURBS curve is a rational B-spline. That is, the control vertices, at least by default, do not lie on the curve itself, but rather lie somewhere off the curve, each having a specific weight or pull that exerts itself upon the portion of the curve. With the NURBS curve still selected, I will click on the Object Data icon in the right Properties panel. This displays the properties for the NURBS curve object. Note first that the NURBS curve is set to be a 3D shape. I can move the control vertices so that the curve object exists in X, Y, and Z space. This is signified in Blender by the arrowheads located along the length of the NURBS curve. The arrows point from the start of the curve to the end of the curve. I will scroll down to the Active Spline panel. There are a number of useful controls located here. The rational weighted aspect of NURBS curves makes them somewhat difficult to predictably control. Usually modelers will checkmark the endpoint checkbox in the Active Spline panel, which forces the endpoint control vertices to lie on the actual endpoint of the curve, in essence giving them a weight of 1.0. This makes controlling the NURBS curve much easier and more predictable. Like the Bezier curve, a NURBS curve can be extended by selecting the endpoint control vertice, holding down the Control key, and left-clicking somewhere in the scene. Another way to do this is to select an endpoint control vertice, and then press the E key, Extrude, and move the new control vertice somewhere in the scene. Like the Bezier curve, a NURBS curve can be closed by clicking Alt-C. Another way to do this is to check or uncheck the cyclic checkbox located in the Active Spline panel. If a NURBS curve is closed, and it is also a two-dimensional curve, it will automatically be filled. This demonstration curve is a three-dimensional curve, so it is not filled upon closing. I'll tab out of Edit mode and delete the NURBS curve object. I'll then go to Top View and have a new NURBS curve object. I'll then tab into Edit mode. In the Shape panel, I'll set the shape to two-dimensional. In the Active Spline panel, I'll checkmark the Endpoint checkbox. I'll select an endpoint, and holding down my Control key, left-click a few times to add more control points and extend the size of the NURBS curve. I will then check the Cyclic checkbox in the Active Spline panel. Note that the NURBS curve is now filled. While I'm still in Edit mode on this object, I'll create a new NURBS curve. and I'll move it inside of the closed NURBS curve. Note that both of these NURBS curves are part of a single object. I will checkmark endpoints in the active spline panel. I'll select an endpoint, hold down my control key, and add some additional control vertices. I'll then close this curve by checkmarking the cyclic box in the active spline panel. Note that when this second spline is closed, it is filled by cutting a hole out of the original closed spline. I can control the inside cutoff and the outside fill by manipulating the control vertices. I'll select one of the control vertices from the outer spline, making it the active spline. Another controller in the active spline panel is called order. Order refers to the depth or degree of the curve. In other words, how much the control points are taken into account for calculating the curve shape. The default is an order of 4. In Blender, the order of a NURBS curve can be set to either order 2, linear, order 3, quadratic, order 4, cubic, order 5, quintic, or order 6, sextic. In order to set a NURBS curve order to 5 or 6, you must have at least 5 or 6 control vertices. The Blender Foundation 2.6x documentation recommends using the 5th order for NURBS curves because it behaves fluidly under all circumstances without producing discontinuities. I will set this curve to an order of 5. I'll then tab out of Edit mode and add a new NURBS curve object. I'll then tab into Edit mode and checkmark Endpoint in the active spline panel. In addition to extending or extruding the control vertices of a NURBS curve object, it's also possible to subdivide them. Here I will select all 4 control vertices and then click on the Subdivide button in the Tool panel. Note that I now have 7 control vertices. I'll manipulate the control vertices to create a sort of double curve. In the Geometry panel, I'll set the Extrude to 3 Blender units. This extrudes the NURBS curve along the Z-axis. I will tab into Edit mode. Note that I still only have 1 curve here, and I can still manipulate the control vertices of that curve. I'll tab out of Edit mode and select the other NURBS object. Here I will also set the Extrude controller in the Geometry panel to 3. This extrudes the filled NURBS curve with a hole 3 units along the Z-axis. In the Geometry panel, I will set the bevel depth to 0.25. This creates a beveled edge on both ends of the object. I'll select the other NURBS curve object. In the Geometry panel, I'll set the bevel depth to 2.25. This creates a beveled edge on both ends of this object. I'll select these 2 objects and delete them. I'll then go to Top View and add another NURBS curve object to the scene. I'll then tab into Edit mode and click on the Object Data icon in the Properties panel, and in the Active Spline panel, I'll checkmark Endpoint. With all of the control vertices selected, I'll click on the Subdivide button in the left tool panel. I'll then adjust the control vertices to create a sort of omega shape. While still in edit mode, and with all the control vertices selected, I'll press Shift-D and make a duplicate copy of this curve and place it to the side. It's possible to connect these two NURBSCurve splines. I'll select the ending control vertice of the spline, and holding my Shift key down, add the opening control vertice of this spline to the selection. I'll then press the F key, which will create a segment joining the two splines. There's another checkbox in the Active Spline panel that I need to demonstrate. I'll tab out of Edit mode and delete this NURBSCurve object. I will then go to Top View and add a NURBSCurve object to the scene. I'll then tab into Edit mode and click on the Object Data icon in the Properties panel. I'll check mark Endpoint so that the endpoints of the NURBSCurve lie on the NURBSCurve itself. Then, with all the control vertices selected, I'll press the Subdivide button in the Tool panel. I now have a NURBSCurve object that has 7 control vertices. 1, 2, 3, 4, 5, 6, 7. One of the checkboxes in the Active Spline panel is named Bezier. Checkmarking the Bezier checkbox makes the NURBS control vertices mimic a Bezier curve control handles. The Bezier checkbox only works when the NURBS curve order is set to either 3 cubic or 4 quadratic. I will set the NURBS curve active spline order to 3. Notice that the endpoint is no longer on the curve. When the Bezier checkbox is selected, it negates the endpoint feature because the endpoints, in this example, now act like Bezier handles. I will uncheck endpoint. When the order is set to 3, all odd control vertices act as a center of a Bezier control point, and all even control vertices act as a Bezier handle. So vertices 1, 2, and 3 define a first Bezier segment. 3, 4, and 5 a second one, and 5, 6, and 7 a third segment. I can select the third control point, and it acts like the outgoing handle of a Bezier curve. Notice that all of the odd-numbered control vertices act like handles and are located directly on the NURBS curve. As noted, the Bezier option works with a NURBS curve when the order is set to 3 or 4. However, when the order is set to 4, the resultant controls are so horribly unintuitive, I'll not even bother to demonstrate them. There are 2 other types of NURBS curve objects I would like to demonstrate. I'll tab out of Edit mode and delete this NURBS curve object. I'll then go to Top View and add a NURBS circle object to the scene. I'll then tab into Edit mode and click on the Object Data icon in the Properties panel. A NURBS circle object is essentially a closed or cyclic NURBS curve object that consists of 8 prepositioned control vertices forming a 2-dimensional circle. It can be used in a wide variety of modeling and animation techniques. For instance, it makes an excellent path for an animation fly-around. Increasing the Extrude controller setting in the Geometry panel creates a cylinder-type object. I'll set the Extrude setting on this object to 3. I will then add some bevel to the extruded NURBS circle object. The last type of NURBS curve object I will demonstrate is called a path. I will tab out of Edit mode and delete this object. Then go to Top View, and I'll add a path object. I'll tab into Edit mode and click on the Object Data icon in the Properties panel. A Blender path object is a NURBS curve object that has its endpoint checkbox checked. It contains 5 control vertices arranged so that it is displayed in a straight line. Its order is preset to 5, and the path animation box is pre-checked. The path object is frequently used, as the name implies, as a path upon which a Blender object or objects can be animated along. However, one can use any NURBS curve or Bezier curve object as an animation path.